Hello class, today's lesson is on solving quadratic word problems. Here's 4 word problems to work on. After we're done with these 4, the next topic we have are inequalities, and that'll be it for this distance learning Algebra 1 period. Here's your first problem. Here's your second. Here's the third. And here's the fourth. I'll also have posted what I would have given you for the quadratics test with a key to most of it. You can work on that on your own time, maybe in substitute for the classwork, just to see how you're doing. So let's begin solving. I have here the first equation, which is the height of a potato after t seconds after it's been launched. So here's the main part. We need that equation. We have to write and solve for when it hits the ground. By sketching a little graph of what it looks like. It looks like it starts up here, right? Because I know this is the y-intercept. It starts at 64, goes up, and then eventually comes back down. I think, yeah. Okay, so then it hits some maximum. We don't know quite what that is just yet. And then we know when it hits the ground, or that's what we're trying to solve for. Hits the ground. We know that for 1a, the equation for it to hit the ground looks like this whole thing, plus 64 equals 0. So here's h of t along your y-axis, along the x-axis, that's time. So we have to solve this thing. As there's many methods for you to solve this equation. I'm looking at this equation and I see they have common factors inside, so I'm going to take those out first and maybe go with the factoring method to solve it. So 16, looks like I can first take out 8. So we have negative 2t. Can we take out 8? Maybe just 2. Can't take out 8. No, 4. Yeah, we can take out 4. Negative 4 plus 15t, and then this one's plus 16. And I think that's the best we can do. When we divide out this whole thing by 4, okay, we're left with just this equation. 15t plus 16 equals 0. We think about, okay, on the side, here's our box and diamond. Negative 4t squared and 16. Together, they make 64t squared, negative. And we have to add up the 15t. 8 and 8 make 64. 7 and 9 make 63. 12. Thinking about the factors here. And if the factors don't come to us, well then we always have our quadratic equation. There's 2, 2, 2, 2, 2, and 2. It looks like we're out of luck. I don't think there is anything here that will get us to 15t. So it looks like this one's not factorable. Yeah. So let's go to our handy dandy. Doesn't look factorable. Could be wrong. So let's use the quadratic equation. There's our a value, and for practice sake, I'll just write out the equation, quadratic equation again, like that. Your a value here is negative 4, b value is 15. So we're filling in the parts. Here is b squared, 15 squared, and it looks like I'll need a calculator because these numbers are large. Probably can't do these all in my head. Negative 4 That gives us negative 15 here, plus or minus. Grab my calculator. I can work through these and then tell you what it is. They also recommend that you take a calculator and work through these yourself. So in testing situation, you know what to work through. Like, you know how to use your calculator, and I'm not there to help you. 4 times 4 times 16 gives us 256. Plus 256, we're fine. All over negative 8. 256 plus 225, 41. All over negative 8. Let's see if we can find the square root of this number. It's about 22. So it doesn't become a perfect square in any means. So it's approximately 15 plus or minus 21.9, let's call it, all over 8. We have our two answers here. Okay, one's plus, one's minus. Negative 15 plus 21.9 all over negative 18. Let's see what that is. Plus 21.9 divided by negative 18 gives us about negative 0.38. And then for this one, where we subtract them, negative 15 minus 21.9 gives us 36. Negative 36.9 divided by 8, negative 8, gives us a positive number, 4.61. As we interpret our solutions here, notice this one, seconds, right? Because we're solving for t, seconds. This one makes no sense, right? The frog can't go backwards in time to figure out when it hit the ground. That means our answer is here. After about 4.61 seconds, the frog, what is a frog? No, the potato has hit the ground, yes. The potato has hit the ground, and that matches our graph, because the other x-intercept would have been like over here. You can see why it's negative, but that didn't occur. That's the answer to part 1a. 1b, it looks like I'll need some more space. For 1b, we look at our equation, and then it wants us to solve that same one, but now when it's 40 feet off the ground. Okay, so for 1b, 40 feet off the ground, that's your height. And now we're looking for the time, okay, when the potato is 40 feet off the ground. H of t represents height, so this becomes your equation. We can't factor or solve it just yet. We have to take away 40 from both sides. 0 equals negative 16t squared plus 60t plus 24. Looks like we can factor out a 6. No, a 4 again. Yeah, looks like it's just a 4. Divide everything by 4. Divide by 4. So we have this thing. Don't need the parentheses. Plus 6. Let's see in our little diamond. Let's see if it's factorable. 24t squared, positive 15t. Add up the 15, multiply to 24, 6 and 4, 12 and 2, 8 and 3, 24 and 1. Oh, we're out of luck again. Looks like this isn't factorable. So we can use the quadratic formula again to solve this one. Should we complete the square? I'm looking. I see that this thing is not even, so completing the square probably wouldn't be such a great idea. I'm probably going to have answers that are decimals. So quadratic formula once more. Yeah, the tough part about word problems is really setting up the initial equation over here. Solving, since we know the quadratic formula now, isn't so bad. There are a lot of steps, so it's worth practicing through all these. 4 times negative 4 times now 6, all over 2 times negative 4. Negative 15 plus or minus, grab my calculator, 15 squared again is 225, okay, and we're adding on to 225, 4 times 16, no, 6, not 16. Okay, so that gives us 321 all over negative 8. I don't think 321 has a perfect square, and it doesn't, but it's about 18, 17.9. Okay, so then we can branch off at this point, plus and minus, negative 15 plus 17.9-ish, all over 8. This one is negative 15 minus 17.9, all over negative 8. So one of our answers is negative 15 plus 17, plus 17.9 divided by negative 8. We get a tiny negative number. Okay, and then the next one, you'll see that this answer does make sense. Negative 8. But this one is about 4.11. Okay, that one is going to be our answer. Again, because you can't have negative time, that's the answer to 1B. Here's the second problem that we're working on. It's very similar to the first, but it asks you a little different question. You also have a little different equation here. Seems rather annoying because there's decimals involved. So when I look at this, I'm probably going to use the quadratic formula. I could multiply everything by 10 here to make them whole numbers, but even then, like 273 doesn't look like it's factorable. So in question A, it says, is the pumpkin in the air after 8 seconds? As I look at this equation, we can sketch a little graph again, seeing that the A value here is negative, right, this thing. It starts 2 meters, starts up 2 meters in the air, so the guy's probably holding it, or that's how far, high up it is in the catapult. Goes up, and then falls down. And to check whether or not, is it in the air after 8 seconds, like is 8 seconds here? Is it here? We don't know just yet. And we can find out by using this equation, figuring out what g of t is. Okay, 2 plus 23.7t minus 4.9t squared. When t equals 8, let's see where the height is. When t equals 8, 2 plus 23.7 times 8 minus 4.9, 8 squared. Put this into a calculator. Let's see what we get. Save some space. Okay, 2 plus 23.7 times 8, 189.6 minus 4.9 times 64, 313.6. So 2 plus 189.6 minus 113.6 gives us negative 122 meters. So that means, if I were using a graph to represent this, 8 seconds would look something like, okay, maybe over here. If 8 seconds were there, it's all the way down here. Okay, and does that part make sense? Not so much. It already hit the ground, and the pumpkin doesn't go 122 meters down into the ground. Okay, so that part of the graph doesn't exist. So based on this answer, right, no, because the pumpkin already hit the ground. Before 8 seconds. 8 seconds have passed. For 2b, we'll solve this equation and figure out what exact time it was. It's probably before. We're looking for this point when t is equal to, right? It's x-intercept when it hits the ground. So 0 equals 2 plus 23, oops. Let's just keep going. Plus 7t plus 4.9, oops, so minus. Make sure you copy down your equations right. So we can rearrange it so it's a bit more obvious, like all the a, b, and c values for a standard quadratic equation. Okay, now it becomes a bit more obvious. Negative b plus or minus b squared minus 4ac all over 2a. Memorize that if you haven't already. 23.7 squared, yep, definitely you need a calculator for this problem. Negative 4.9 to 2 times negative 4.9. Joy. Negative 23.7. I'll do this stuff on my calculator and just tell you what it is. 23.7 squared plus 4 times 4.9 times 2. Okay, square root of 689. Let's see what that is. Ooh, okay, nice. So that's about 23.7 plus 24.5. Negative 9. We have our two answers. One's plus, one's minus. Here's the plus, there's the minus. Negative 23.7 plus 24.5 over negative 9.8. Here we have negative 23.7 minus 24.5, 9.8. Let's figure out what those values are. Okay, this one's wrong. This is the answer that makes no sense. Again, negative seconds doesn't make any sense here. It was at the ground in the past. It's at the ground at some point. Oh, there we go. So this is the positive answer, 9.81 seconds. Cool. So that's when it hit the ground. Solve for when it equals 0. Height is 0. That's where the ground is. And now we know at this point that is 4.918 seconds. We have two more problems to practice. Most of them are this, like, is this projectile motion idea. Okay, either something jumping, something being thrown, something being launched. That's all quadratic behaviors. Right, a little bit simpler equation. A frog now's height is modeled like this. Solve for this equation. Notice this one doesn't have a y-intercept. So our graph means that not having y-intercept means 0, 0. Our frog's path looks like this. Starts at the ground, ends at the ground. 75t squared. To solve this one, we can factor out, even more than that. Let's factor out 5t. That gives us 12, gives us 15t. Well, I could factor out like 15 from this. Let's keep going. So we take out another 3. So if I were to show my work better, I already have out 5t, and I'm taking out another 3, 4, and 5t. like so. That gives us 15t and 4 minus 5t. So by 0 product property, 15t equals 0. T has to equal 0 here. That's one answer. And the other one equals 0. Minus 4, negative 5t equals 4. Divided by 5, divided by 5, t equals 4/5, or 0.8 seconds. What does this solution tell us about the jumping frog? Well, it took him less than a second to go back to the ground. He probably took really short hops. And yeah, you could figure out the maximum here. Remember, that's halfway in between. Could figure out maximum. So this is more like a hint to one of the problems from your exit ticket. Use negative b over 2a, find the center, then find the height. Or you could complete the square, turn this into vertex form, and see where the vertex is, your choice. 3b. What do the solutions tell us about the jumping frog? Went some height, took less than 1 second to come back down. He started at the ground. So unlike the the pumpkin and the potato from earlier, they didn't start like up in the air. Because they're in a catapult, they were a little bit up in the air. Right? This frog started at the ground, ended at the ground. Last question. 4. We have something similar. A tennis ball is launched straight up. This one does have a y-intercept over here of 4. Come on, 4. Ooh. Looks like that. Find solutions. Another factoring. This one, I think this one's factorable. So then I'm rearranging it so that I see in case we do have to use the quadratic formula. Yeah. No, it doesn't. Oh, yeah, it does. It does. Yes, it does. Okay, this one does end up being factorable. So then it becomes the boxes and a diamond. So I got an email and just checked, and the teacher was telling me how my favorite short story, The Paper Menagerie, was a big hit amongst her classes. And if you haven't read that story already, do read it. It's on Piazza. Plus 4t, and here's negative 1t. There's 4, there's 1t, there's 4. Oh, here has to be a 4. This is the 1. One of those is negative, I don't know which one just yet. Looks like it has to be this one. Like so. So then 4t plus 1, and then negative t plus 1 by 0 product property. 4t plus 1 equals 0, t equals negative 1/4. Doesn't make any sense. So that means it's going to be this answer. So the tennis ball here was started up 4 feet in the air, right? Because that's when you would hit the ball. It's going to be off the ground. It takes a second for it to reach back down on the ground. So there was some force applied to this one. No, gravity. Right. Gravity is applied. And that's the end of today's lecture.